Welcome to video 2 for this unit on Introduction to Quadratic Functions. In this video, we're going to focus on building quadratic functions. The distance traveled by a falling object in a given amount of time is an example of a quadratic function. Galileo is said to have dropped cannonballs of different mass from the Leaning Tower of Pisa, which is about 190 feet tall, to show that they travel the same distance in the same time. In fact, the equation d equals 16t squared models the distance d in feet that the cannonball falls after t seconds, no matter what its mass. Here's a table showing how far the cannonball has fallen over the first few seconds. Here are the time and distance pairs plotted on a coordinate plane. Notice that the distance fallen is increasing each second. The average rate of change is increasing each second, which means that the cannonball is speeding up over time. This comes from the influence of gravity, which is represented by the quadratic expression 16t squared. Let's look at this example another way. Another way to study the change in position of the cannonball is to look at its distance from the ground as a function of time. Here is a table and a graph showing the distance from the ground in feet at 0, 1, 2, and 3 seconds. The expression that defines the distance from the ground as a function of time is 190 minus 16t squared. It tells us that the cannonball's distance from the ground is 190 feet before it is dropped and has decreased by 16t squared when t seconds have passed. Let's look at an example where an object is being thrown upwards. An object is thrown upward from a height of 5 feet with a velocity of 60 feet per second. Its height, h of t, in feet after t seconds is modeled by the function h of t equals 5 plus 60t minus 16t squared. Notice that the graph intersects the vertical axis at 5, which means that the object was thrown into the air from 5 feet off the ground. The graph indicates that the object reaches its peak height of about 60 feet after a little less than 2 seconds. That peak is the point on the graph where the function reaches a maximum value. At that point, the curve changes directions, and the output of the function changes from increasing to decreasing. We call that point the vertex of the graph. Every quadratic function has a vertex, the point where the graph changes from increasing to decreasing or vice versa. It is the highest or lowest point on the graph. The object hits the ground a little before 4 seconds. A 0 of a function is an input value that produces an output of 0. A 0 of function h is approximately 3.8 because h of 3.8 is approximately 0. Quadratic functions often come up when studying revenue. Revenue means the money collected when someone sells something. Suppose we are selling raffle tickets and deciding how much to charge for each ticket. When the price of the tickets is higher, typically fewer tickets will be sold. Let's say that with a price of d dollars, it is possible to sell 600 minus 75d tickets. Then the revenue collected is R of d equals d times the number of tickets sold. Here is a graph that represents the function. It makes sense that the revenue goes down after a certain point, since if the price is too high, nobody will buy a ticket. From the vertex of the graph, we can tell that the greatest revenue, $1,200, comes from selling the tickets for $4 each. This function has a 0 at a price of $8 because no tickets are sold, so the revenue is 0 when the price is $8. This function has another 0 at a price of $0 because the tickets are free, so the revenue is 0 when the price is $0. Thank you for watching video 2 of 6 for this unit on Introduction to Quadratic Functions.